In this lesson, we'll be looking at what is direct proportion. This relates to two variables which are directly proportional to each other, only if one of the variables is a constant multiple of another. So an example of that would be something like y equals 2x, where y is double of x, or y equals 10x, which is y is 10 times of x. Okay, you could also have negatives such as y equals negative 5 times x as well. So as long as there's a number before the x, like that, then that means y is directly proportional to x. Now, in this case, in general, what happens if y is directly proportional to x, then what we say is y equals to kx, where k is just some number, where it's a constant. Okay, so I've written that here. And that constant is called the constant of proportionality, or the constant of variation, right? So if you have y equals to kx and x increases, so this value of x increases over time, what happens to y is that it also increases. So whatever x does, y does the same as well. Now, if x decreases, then y also decreases. If x doubles, then y also doubles. And if x halves, then y also halves. Okay? Right. Now, we know that whenever we draw some kind of equation relating x and y, if you have y is equal to mx plus b, okay, then it's going to be a straight line. In this case, you've only got kx, okay? So instead of the m, we have a k, and that represents the gradients. And there's no y-intercept, which means it's an invisible plus 0 like that. And so what that means is it's a straight line that passes through 0, 0, okay? So it would look like this, passing through 0, 0, because there is a 0 here as a y-intercept, and a k here as our gradients. Okay? Now let's have a look at a few questions to do with the exercise. Exercise 801. The distance d traveled by Craig, a marathon runner, varies directly with time t. So what this means is, if we have a look at the table, as time goes by, okay, as time increases, the distance traveled by Craig also increases, and that makes sense. Okay, the more time goes by, the more distance you cover. He's running more distance. Now, question A, write a variation equation for D. So we start off by writing D, it's capital, equals to K, okay, times the time, all right? So instead of y equals to kx, we have d equals kt now. And what we need to do is find this constant variation. That's the first step to do that. So what we do is we substitute in a pair of values to do a t and d. So it could be these two, or it could be these two, or it could be these two. But I'll just start with the first pair. So I'm just going to substitute in t as 1 and d as 190. Okay, so what happens there is that d is 190, and that equals to k times 1 if we substitute it to those places here. Then that means 190 would equal to k. Right? Now, once we've actually got that k value, we can substitute this back into the equation. So that therefore, d equals to 190 times t. In words, what this means is the distance is 190 times the time. Okay? Now, look at question B. How far in kilometers, which is d, the distance, will Craig run in 20 minutes? So we've got t here as 20 minutes. We're going to substitute that right in. So part I, we'll have d equals 190 times 20, and that will be 3,800 meters, or 3.8 kilometers. For part 2, how far in kilometers will Craig run in 45 minutes? So we substitute in 45, so that will be 190 times 45, and that will be 8,550 meters, right? See, how long would it take Craig to run 0.35 kilometers? So this represents our distance here. So we're going to sub in distance as that value there. So that means we'll get 12.35 equals to 190t. So to solve this equation, we have to divide both sides by 190. So that t goes by itself. Now when you do 12.35 divided by 190, right? Okay, let me just check this. Oh, you know what? I've done it wrong. Okay, it's actually not 12.35. It's something else. Because if we look carefully, I got tricked by this question. This is in kilometers, whereas this is in meters. Okay, so I've got to actually convert that 12.35 to meters first, and I need to multiply that by 1,000. So if I get 12.35 times 1,000, I will get 12,350. That's equal to 190 t. So then if I divide both sides by 190, okay, now that will give me the correct time. So last time I was getting like 0.065 minutes, which doesn't make sense, okay? You can't travel that much in such a less time. So the actual answer now is t is equal to 65 minutes, which does make more sense to travel that many kilometers. Okay. So the question says to answer in hours and minutes. So this is the same thing as 1 hour and 5 minutes. All right, let's go into question 2. Meda's earnings for working a shift at the local nursery are directly proportional to the number of hours she works. So the more she works, the more she earns. Yesterday, she earned this much for working an 8.5-hour shift. If Meda's earnings are represented by E, and the number of hours worked is represented by H, write an equation for E. Okay, so for part A, if you want to write an equation for E, then we write E, our earnings, is a constant, which is K, times by another letter, which is H, the number of hours. So we got to find out what K is. And to do that, we got to substitute in something to do with her earnings as well as the number of hours. So that's the thing I've highlighted. I'm going to substitute in E as that and H as 8.5 hours. So 222.7 is equal to K times of 8.5, which is exactly the same thing as 8.5K. But if I divide now both sides by 8.5 to find what K is, hopefully gives me a nice number. Let me try that out. So 222.7 divided by 8.5, that gives me exactly 26.2. That's perfect. Now I'm going to substitute this back here right after I'm done with that. Okay, so therefore my new equation for E is equal to 26.2 H. Okay, so basically to get my earnings, I get $26.20 times by whatever hours I get to work. And so that's my hourly rate. So for part B, how much will she earn for working a 7-hour shift? E will equal to 26.2 multiplied by 7. So if I multiply that by 7, I will now get $183.40. For part C, how many hours did she work today if she earned that much for the shift? Well, that represents E for the earnings. So if I replace that letter by that number there, get $144.10 equal to 26.2H, which now leaves me to divide both sides by 26.2 to find out what H is. So if I cancel that out, 144.10 divided by 26.2 would give me 5.5 hours, so 5.5 hours of work. All right, let's move on to question 3. The amount of interest earned for 1 year on an investment account varies directly with the size of the deposit. So the more you put money in to your bank account, the more interest you earn on that. So if Katerina earns $16 interest on an investment of $425, find the variation equation for I. So two letters we're relating are interest and deposit. So the size of the interest is directly proportional to D, the deposit. So we're going to find K by substituting in some information about the amount of interest earned on an investment, okay, or the deposit. So this is the I, this is the D value. So 16 would equal to K times 425. Now if I divide both sides by 425 to find out my value of K, that will cancel out. So 16 divided by 425. Now the decimal that it puts in the calculator is quite messy, it's quite long. We're not going to write that. So if ever possible, which should be always possible because we're dealing with a fraction here, write that as a fraction rather, like this. Okay? So therefore, if I substitute this back in here, then I would equal to 16 over 425 times of D. For question B, hence, how much will she earn on an investment of $900? So an investment of $900 is our deposit. Okay, so that's our deposit D. They put $900 into the bank and wants to know how much interest or extra money they'll earn. So we're going to substitute that as D in here. Okay, so we'll multiply 16 over 425 by 900. And what we'll get is I equals to 33.882, etc. There's more numbers after that. So to two decimal places, because we're dealing with money, we're going to write $33.88, like that. C. If Katarina's uncle doubles the size of her investment in B, how much will she earn in interest? So the investment in question B was $900. Okay, so what happens if we make that double? Okay, so double of 900 is $1,800 or $1,800. If we now put that as a deposit right there, how much interest would they earn? Well, you multiply that with 16 over 425. Okay, so let me do that. And that will give us 67.764, which is approximately $67.76. And that's basically double the amount of interest previously. So if you double the deposit, then you double that interest to become this over here, right? So that means our direct proportionality works, right? So that interest is directly proportional to D. Right, let's move on. Question 4. S varies directly with T. That means we can write S equals KT. If T equals 14, S is 106.4. What is the value of S when T is 0.3? So let's substitute this in to find the value of K. S is 106.4 and T is 14. So we substitute that in and undo that times of 14 by dividing it both sides by 14. And what we get is 7.6. And we put that back into our original equation all the time to find out our final equation without the K value there, but instead substitute it in with 7.6, like that. And so we're trying to get the value of S, which is this, when T is 0.3, which is that. So we're going to substitute T in, 0.3. We multiply that by 7.6, and that will give us 2.28. Okay, so the answer is A. Our next question, question 5, involves a table. Find a linear formula for B in terms of A for this table of values. So usually you have Y and X here. So that means you can write Y equals KX. But instead of Y, you have B, and instead of X, you have A. So what that means is you can write B equals KX, and K here would represent the gradient of this line if it was drawn. Okay, so this line would be like this, and you actually find the gradient. But to find the gradient, or this value of K, we have to substitute in two values, which is one for B and one for, this is A. Okay, so one for B, one for A. So we're going to substitute in maybe this pair, or this pair, or this pair, but the easiest one will be the smallest numbers. So we substitute in B as 10 and A as 4. So it's K times 4. So that allows us to find out what K is straight away by dividing both sides by that 4. That will cancel, so therefore K is 10 divided by 4, which is 2.5. So we put that back into the equation, so that B is equal to 2.5 times of A. Okay, and that's our linear formula. That's basically it. Doesn't ask us to find any other value.